In section 7.4, we're going to be looking at properties of special parallelograms. And as you can see right here, I have this flow chart shown, and I'm going to eventually give it to you guys. Um, it shows properties of quadrilaterals. And so far, what we've been looking at are quadrilaterals over here on the left-hand side of the flow chart. And so we're going to be going over all of these parallel or quadrilaterals throughout this, eventually in this chapter. So far, we've looked at parallelograms. And what I want you guys to do is eventually list all of the different characteristics of a parallelogram. You could write it out in there, or you could probably type it out on the side using Cami. You know, opposite sides congruent, opposite sides parallel, opposite angles congruent, diagonals bisect. Those are all different characteristics of a parallelogram. Now, in this flow chart, and what we're actually going to begin to look at today are the other characteristics underneath the parallelogram. For example, we have a rectangle. We have a rhombus. Now, one thing I want you to understand as we go through the properties of quadrilaterals is that, all of these shapes or polygons on the left-hand side, the parallelogram, rectangle, rhombus, square, they're all quadrilaterals. They're all four-sided figures. The difference is that, look, as we get down on the flow chart, it becomes much more specific as far as the characteristics of the quadrilateral. Now, when we say, is everything a quadrilateral with its four sides? Yes. So everything that's listed underneath the quadrilateral, the trapezoid, the kite, all that stuff happens to be quadrilaterals. But are all quadrilaterals parallelograms? Well, no, because that's why the quadrilateral branches out to the parallelogram. It branches out to the trapezoid and the kite. So not all parallelograms are quadrilaterals. Okay, but all quadrilateral but quadrilaterals can be a parallelogram, trapezoid, kite. But are all parallelograms quadrilaterals? Yes. So going downwards, we get a little more specific. But as we move up on the lists, you'll see that not all the characteristics coincide with each one. Some do. So when we take a look at a rectangle right here, well, a rectangle, one of the things that we need to understand is that it has all the characteristics of a parallelogram. Opposite sides congruent, opposite angles congruent, opposite sides parallel are parallel. And when we take a look at this rhombus right here, all of the characteristics of a rhombus are that of a parallelogram as well. But a rhombus has some characteristics that a rectangle doesn't, and that's why it got split off. And then the rectangle and rhombus, they both have characteristics of that of a square. That's why they combine together. If we take a look at your flow chart, they're both right now, at this point, they all connect to the square. So the square has the characteristics of a rhombus, has some characteristics of a rectangle. It's definitely a parallelogram, and it's definitely at the top a quadrilateral. So those are all the different parts or properties of quadrilaterals that are four-sided, but they all stem from that family of a parallelogram. So let's take a look at more detail of these quadrilaterals, or with this special parallelograms. So we're looking at our core concepts right here. Let's start off with the rhombus. It says a rhombus is a parallelogram with four congruent sides. But once again, a rhombus has all the characteristics of that of a parallelogram. Next up, what makes a rectangle special? A rectangle is a parallelogram with 4 right angles. Okay, that's the little extra part to making a rectangle special. So not only is it a parallelogram, it's also shares or also has 4 right angles. And then we have a square. A square is a parallelogram with 4 congruent sides and 4 right angles. Okay, so you can see that, remember in the flow chart, the square was at the very bottom and we had rhombus and rectangle connect to that square because the square shares characteristics of a rhombus, characteristics of a rectangle, and also those of a parallelogram. All right, so that's kind of what I want you to hopefully understand as we took a look, as we looked at all of the different parallelograms and where they fall along in the tree or hierarchy of these special parallelograms there. So let's take a look at this 7.2 corollary. The rhombus corollary states that a quadrilateral is a rhombus if and only if it has 4 congruent sides. So if it has 4 congruent sides, you got yourself a quadrilateral, or a quadrilateral is a rhombus. So these are characteristics that you're going to want to put in that flow chart as well to help you understand, all right, what are some of these characteristics of the rhombus? The rectangle corollary, a quadrilateral is a rectangle if and only if it has 4 right angles. All right, you should already know that the angles are right angles. Once again, with the square corollary, we have a quadrilateral is a square if and only if it's a rhombus and a rectangle. It's got both combined. You can look at the diagram right there, and you can see all sides are congruent, and we got ourselves 4 right angles. Okay? In a parallelogram, opposite sides are congruent as well. So therefore, you see those characteristics right here in a square. Next up, we got theorem 7.11, which is our rhombus diagonals theorem. In this one, a parallelogram is a rhombus if and only if its diagonals are perpendicular. Now that's something new. Okay, we haven't dealt with diagonals being perpendicular. So this right here is an important characteristic, a new one of a rhombus. In theorem 7.12, we now have a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Okay, so you can see when you look at the diagram, you can see where we have these markings, angle markings, showing that, hey, these diagonals are bisecting the opposite angles. All right. We know that in a parallelogram, opposite angles are congruent. But now, if in a rhombus, they are also going to be bisected. Think about this. What else will have the diagonals be bisected? Think about the flow chart. What's below the rhombus? It's the square. So the diagonals of the square will also be bisected as well. Because remember, the square has all of the characteristics above, which is the rhombus and the rectangle and the parallelogram. All right, take a look at 7.13 right here. In this one, a parallelogram is a rectangle if and only if its diagonals are congruent. Okay, so in this one, the diagonals, you can see they are all congruent and they are all bisecting. Okay, they all happen to be the same right here, and that is a big difference between the rectangle and just that of a parallelogram, right? Because in a parallelogram, the diagonals bisect each other, but they're usually all four segments are not the same. Let's take a look at our extra practice. All right, so you have to use some thought. You have to think about all the different characteristics of a parallelogram, from a rhombus to a rectangle to that of a square, to determine, all right, these statements to be always, sometimes true, and then we could draw a diagram to explain the reasoning. So for any rhombus, MNOP, decide whether the statement MO is congruent to NP. Is that always or sometimes true? And then we go and draw a diagram. The diagram is probably the best thing to do for us to start, best way for us to start off. All right. So let's take a look right here. Let's go ahead and draw something out. If I have right here, we've got a rhombus. And now remember, a rhombus has the characteristics of that of a parallelogram. Let me go ahead and label this M, N, O, P. And it says, decide whether the statement MO is congruent to NP. So if I look at M to O and N to P, we're saying that we've got a segment going from M to O, and then we have a segment going from N to P. Are those segments true all the time? In this example, when I have my parallelogram, slanted, going sideways, we should know that the diagonals bisect each other, but they're not going to be, they're all four diagonals or the segments are not congruent. Okay? Now, if I had right here, if I drew this as a rectangle, or something like so, we have M, N, O, P, then in this instance, yes, that would always happen, but that's not the case. So I showed right here, I gave like a counter example to this, proving that it's not always congruent. And so right here, we can go ahead and say that this is sometimes. And that some rhombuses, and then think about this. Some rhombuses are squares. Okay, so if MNOP right here happen to be more specifically a square, well, but this time around all sides are congruent, therefore making the diagonals all congruent because the square has some of the characteristics of a rectangle, thinking about that flow chart. All right, so that makes this sometimes, and the big thing right here is understand that some rhombuses are squares. That makes it sometimes. Let's take a look at number 2. It says for any rectangle, decide whether the statement angle PQS is congruent to angle RSQ. So let's go ahead right here. Let's draw our rectangle. And we got ourselves P, Q, R, and S. And how can we draw angle PQS? So angle PQS looks like right here. What I'm going to do is I'm going to have to draw a diagonal right there. So we're looking at angle PQS, going with that blue line or diagonal. And then we have angle RSQ. So what we're saying right here, we have RS to Q. And so it happens to be that same diagonal. We're looking at this angle right here. And there's PQS right there that I put with a blue dot to represent that. And so if this is a rectangle, what can we say? Well, remember, a rectangle shares characteristics of a parallelogram. We have two parallel lines, PQ and SR. Q to S, that right there is like it's your transversal. So what we could say is, well, knowing that these two angles right here, they're alternate, interior angles. So what we could say here is this. And we could say that these two, that statement right there is always true. All right, how can we say it's always? Once again, I gave some of those characteristics of a parallelogram. So I can go ahead and say that a rectangle is a parallelogram, meaning that we're going to have all of those characteristics of a parallelogram right here. Opposite sides are parallel. I'll go ahead and put that. And then more specifically for our third one, we have alternate interior angles are congruent. Okay, and we could say are formed by the diagonals, or the diagonal that we have there. So it's important to make sure you list your characteristics of these special parallelograms so that you know, hey, what does the square have that the parallelogram doesn't, or the square have that the rectangle or rhombus doesn't? Okay, and then kind of you start eliminating or realizing, all right, the rectangle has these characteristics, the square does not, or the rectangle has this, the rhombus does not. And then you can better determine and come out your conclusions on these types of questions. Let's go up next to number 3. So it says in 3 through 5, the diagonals of a rhombus A, B, C, D intersect at E. And then we given that measure of angle BCA is equal to 44 degrees, AB is equal to 9, AE is equal to 7, and then we find the indicated measure. So let's think about what we know about a rhombus, okay? In a rhombus right here, we should know that the diagonals, they bisect each other. So let's see. We could say that AE right here is congruent to EC. We should know that D to E right here is congruent to B to E. But what does that do for us with B to C? Okay, so they list some of those special characteristics there. They give us A to E is 7. So that means that E to C is also 7. And based off of one of our main characteristics of a rhombus, remember, opposite sides are, all sides are congruent. So we can go ahead and, if we know that AB is 9, then B to C is going to be 9 as well. Remember, all sides congruent. Let's take a look at A to C. Okay, so A to C right here is this whole entire diagonal. Let me go ahead and highlight that right here. And so part of it, A to E is 7. But remember, the diagonals bisect each other, telling me that E to C is 7. So for a grand total, of 14 for A to C. And then let's take a look at number 5, the measure of angle ADC. ADC. Okay, now remember, in a rhombus, we should realize that the diagonals bisect each other. So let me go ahead and delete that. If the diagonals bisect each other, this angle right here, I'm going to highlight, angle DCE, is 44. One thing that we just discovered is that the diagonals are 90 degrees. Okay, when they intersect, they form right angles. So now what I can find is this angle right here, angle EDC. And how do I do that? Well, I should know that in a triangle, because we have a triangle right here. The triangle adds up to interior angles is 180. So that missing angle right there happens to be 46 degrees. So once again, if the diagonals bisect, then I can now figure out that angles ADB right here, or ADC. So this is 46. That makes this right there 46. And that will give me a grand total of 92 degrees for angle ADC. All right. Let's take a look next up at number 6. So this time we're looking at a rectangle. And we have ourselves rectangle EFG intersects at I, given that HFG is 31 degrees. They show that to us right there. And E to G is equal to 17. All right, so E to G, this whole entire thing right here, that let's go ahead. E to G, that is 17. And so let's figure out what is the measure of angle FHG. So where is FHG? Is right there. Well, once again, we have ourselves parallel lines because we're dealing with a parallelogram, essentially, with a rectangle. If this angle right here is 31, then the angle, let me go ahead and highlight that with yellow. That makes this angle right here is 31. Okay, alternate interior angles. Well, then how do I figure out this angle IHG? Well, remember, we have a rectangle. In a rectangle, the vertices happen to be 90 degrees or perpendicular. So what I can do is take 90 and set that equal to angle IHG, or FHG for that matter, since that's our problem, plus 31, and that'll get us that missing angle. So we have angle F, HG, when we subtract 31 to both sides right there, we will end up with 59 degrees. All right. Fantastic. E to G is 17. So that'll help us with number 7 because they're saying, well, let's find H to F. The diagonals right here are going to be they're all congruent in a rectangle. So if this whole entire diagonal for F, E to G is 17, then H to F will be the same thing as well and also be 17. Let's take a look next up at number 8. We have angle EFH. Where's E, F, and H? Okay, so we're taking a look right here. Angle EFH is at the top left, or sorry, top right angle. And if I look, I may even match it up with the colors, alternate interior angles, they're congruent. And we found out earlier that this angle FHG is 59. Right, so if that's 59, then that's going to make this one 59 as well. So if this is 59, angle EFH is also 59, which is our answer of 59 degrees. All right, and then lastly, let's take a look at some of these characteristics of a square. So we have the diagonals of a square, L, M, and P intersect at K. Remember, in a square, it has characteristics of a rhombus, it has characteristics of a rectangle, and that of a parallelogram. Has the best of all worlds right there. So let's see. What do they tell us? MK is equal to 1/2. Remember, the diagonals of a rectangle should all be congruent, so P to K is 1/2. Maybe we'll need to know that. K to N is 1/2, L to K is 1/2. But they say, what is P to K? All right, hey, we just figured that out. That is 1/2, right? The diagonals bisect each other and therefore are congruent, just like that of a rectangle and also the rhombus. Number 10. What is the measure of angle PKN? All right, so let's take a look right here. We're looking at angle PKN. Okay. So how do we do that? They don't give us all that much information. Well, we can come to our conclusion two different ways. One, if you think about angles like in a square, we know that all the angles should be 90 degrees. One of the things we know about a rhombus is that the diagonals bisect the angles. So what that could tell me is that this is 45 right here. Angle KPN is 45. Angle KNP is 45. So that's something I could figure out as well. Knowing that we have ourselves a triangle right there, well, the interior angles of a triangle is equal to 180. So 45 plus 45 plus that missing angle that we need, PKN, all that's equal to 180. So angle PKN is equal to 90 degrees. I could also realize this, is that remember, when it comes to a rhombus, what happens with the diagonals? The diagonals intersect and form 90-degree angles. And right there, we could have also figured out our answer as well of 90. Let's take a look last up at measure of angle M and K. So we have M, N, and K, which is that right there. Now remember, we have a square, so now that we know that one of these angles is 45, or realizing that a square, that the angles are being bisected, M and K is 45 degrees. And so now you have all the properties of a parallelogram. And you could be able to solve for most of these angles and sides and diagonals. All right, make sure you guys fill out that parallelogram flowchart or quadrilateral flowchart and start filling it out, because that'll be one of your assignments. All right, there's 7.4.